All right, let's take a look at 10.9, synthetic division of polynomials. Often when I teach this in class, I teach 10.9 before 10.8, just in case students want to use the synthetic division method while working on 10.8. Synthetic division just helps us work a little faster through the division algorithm. I'll show you this and we'll talk about it as we move through it. But this should look familiar. We're dividing a binomial into this kind of a longer polynomial up top, and I'm going to show you how synthetic division works. What I want to do to decide if I can use synthetic division is I look at this binomial on the bottom here, and I have to look at a couple things. Number one is that I want a 1 right here when I use synthetic division, and I want this to be to the first power. And so when I look at this, it's one I could use synthetic division on. Okay, so what I'm going to do here is focus in on this -2, and I'm going to change the sign. Okay, so this is just a template I'm going to use for synthetic division. So I put this 2 here, and from changing the sign. Okay, so to change the sign there. And then what I'm going to do is I'm going to peel off the coefficients here of this polynomial. So I have 1, -3, 8, -5, and 14, -14. Okay, be careful to pull the signs off there. And I'm going to draw a line here and leaving kind of a little space there. Okay. So what happens here with, and remember, this was x to the 4th, this was x to the 3rd, x to the 2nd, x, and this was our constant. We had every place value represented. If we were missing one, we'd want to put a 0 as a placeholder. Okay. So what I'm going to do here is, to get started, it's a very simple process. All I do is I drop that number. Okay. So there's no math there, I just drop the number. Okay, 1. And now it's a repetition of multiplication, add, multiplication, add, multiplication, add. So we're going to just see a lot of repetition here. So I take this, that's where the multiplication takes place. Okay, so 2 times 1, and I just put my result here. It's kind of, you'll get this flow, little diagonal flow. 2 times 1 is 2, so I'll put my result here. And then I'm going to add these 2 numbers together. Okay, easy enough, -1. And then I'm going to repeat that process. Okay, so 2 times -1, put the result right here. Okay, so 2 times -1 is -2. And then I'm going to add these numbers together. 6. 2 times 6, 12. Add these numbers together, 7. 2 times 7, 14. Add these numbers together, 0. This here, the last one, that's the remainder. Okay, so this problem, no remainder. So how do we write our answer? Well, what we do is we look up here at that x to the 4th, and we knock this down 1 degree. So knocking it down 1 degree is going to be x to the 3rd. So this is going to be 1x to the 3rd. I'm just going to put the 1 there to show you wouldn't write it. You write 1x to the 3rd minus 1x squared plus 6x plus 7. Okay, and then I'm just going to draw a little red line through those 1s, because remember, you wouldn't write those when you write your answer. So your answer would look like x to the 3rd minus x squared plus 6x plus 7. That would be what you type in. Okay, so with synthetic division, make sure that you have the things that you can actually use synthetic division. Okay, and then you want to have this in descending order. All right, so let's take a look at the next one. Okay, check it out for synthetic division. Okay, we have a binomial coefficients 1 to the first power. Looks good. So I'm going to write down 3. And then I'm going to take my coefficients off. That's y to the third. That's y squared. And this is y. And this is the constant. We have every place value represented. Draw my line. Going to drop this number right here. So I have 1. Then 3 times 1 is 3. Add that together is -9. 3 times -9, -27. That's getting to be a kind of not larger, but absolute value is larger number. So I'm starting to think that I make a mistake, but I'm pretty sure I've multiplied correctly. When I multiply here, I get 102. So I get -102, and I get this crazy remainder of -109. Okay, but that's all right. We just write our answer out. And remember, this was at y to the third. So we're going to knock this down 1 degree. So we have y squared minus 9y minus 34. And then we have to handle our remainder like we did in section 10.8. We put the 109 and we put our minus sign because of the negative. And then we put it over what we divided by. Okay, so there's our answer. Okay, kind of strange looking answer, didn't divide in there evenly, but you can see the synthetic division is quite helpful in moving through this a little quicker. Okay, so let's look at this last one here in this video. We changed the sign on this, so I have 3. I'm going to write down 3, 0, 0. I'm kind of losing space, or losing my place here, so I'm going to make some notes to myself. This is x to the fourth. This is x to the third. This is x to the second. Well, I don't see any x's either, just plain old x to the first power, so I'm going to have another 0. And then my constant, I use a C just to say constant, or you could use a number sign. Some students do that. I have -14. Okay, so don't forget to put these placeholders in, okay, and work in descending order. I'm going to draw my line. The math here shouldn't be hard, okay? You just the setup and the algorithm is a little different, but I'm gonna drop this here. Okay, I get 3. That's my starting number. 3 times 3 is 9. Add that together is 9. 3 times 9, 27. Drop 27. 3 times 27, 81. Drop 81. It's kind of growing here, but we're just going to keep working with it. 3 times 81, 243. Okay, and then 243, that's going to be 229, I believe. Hopefully my calculation was right there. So there's my result. I just have to write out my answer here, and what I'm going to get is, remember, this was x to the fourth, so we knock this down a degree. 3x to the third plus 9x squared plus 27x plus 81, and then this was my remainder, so I have plus 229 over what we divided by, x minus 3. Big messy answer. Remember, you're just kind of learning this algorithm, and hopefully it works out for you. A nice thing to do would maybe be take one of these problems and work it with long division and work it with synthetic division and compare your answers. I'd maybe pick one that doesn't have a remainder. It really doesn't matter, but it's nice to make that comparison between synthetic division and long division and see that you get the same result. Okay, that wraps up chapter 10. We'll move on to chapter 11. Thanks.